Okay guys, in today's lesson we will be representing linear non-proportional relationships. So remember what a linear function is. A linear function is a relationship with a constant rate of change represented by a graph that forms a straight line in which each element of the input, normally known as the x values, is paired with exactly one element of the output, usually known as the y values. Our slope, also known as our rate of change, is the steepness of a line, aka rate of change, in y vertical compared to change in x horizontal. Our different rate of change methods, which we have talked about, but let's go over it one more time. Tabular, usually we have change in y values over the change in x. Pretty much, like I said, the triangle here represents change in y over change in x. Or we can represent it as y2 minus y1 over x2 minus x1 if you choose to use 2 points. If graphical, this is when we have a graph, we can use slope equals rise over run. And algebraically, looking at the equation y equals mx plus b, you can solve for the equation y. Once again, you'll get this form, and the slope is represented by the m value, the number in front of the x, or the number in front of the independent variable. Typically we use x and y's, but sometimes I'll use something different. Now our y-intercept is the y-coordinate of a point at which the relationship crosses the y-axis, meaning the x-coordinate is equal to 0. Denoted as b and y equals mx plus b, so the b is your y-intercept. And also the ordered pair 0, comma b. Once again, that's stating that when x is 0, we find out what y is, and that is our y-intercept. A linear non-proportional relationship. This is different than proportional relationships. Once again, it's linear, but this time it does not pass through the origin of 0, comma 0. This time we'll have another number for our y-intercept other than 0. If the number is 0, it's proportional, so we're looking at non-proportional, so it cannot pass through 0, comma 0. And once again, represented by y equals mx plus b, where b is not equal to 0. So once again, if it was proportional, b would be 0. And if it's not proportional, this b cannot be 0. Okay. Going through some things. Let's look at some sample problems here. It says the table below indicates a linear relationship between x and y. Which equation would generate the values in this table? Pretty much, let's go look for our linear equation. In this case, to find, well, we're going to look for the format y equals mx plus b. So first, let's go look for our slope. This guy right here. A couple of different methods we can use, but in this case, I'm going to use my slope is equal to the change in y over the change in x. Okay, what that means is, let's look at our y. We go from 5 to 9. We can see 5 to 9, that's a change by positive 4. Once again, if you look from 9 to 13, once again, positive 4, or 13 to 25, well, there's a big difference there. That's actually going to be, it jumps up by 12, positive 12. And I'm doing this, you only have to choose one change in y over change in x. But I'm giving you a couple examples here. When we went from 5 and 9, we had a change in 4. And at the same time, we went from 2 to 4, we had a change of 2, or positive 2. So, if we do that case, we have change in y is 4, positive 4, over our change in x, which was positive 2. And of course, simplify, well, we can just do 4 divided by 2, and we get 2. Okay, so our slope, in this case, is 2. I want to look at this other example. We went from 9 to 13. Once again, we had a change of 4 over, see, in this case, we went from 4 to 6 now with an x. Once again, that's another positive 2. So, sorry here, let me erase. Change of 4. 4 over, well, once again, change of x is 2. So 4 divided by 2 is 2. So see, we get the same result. Let's look at that last one, because I bet y'all are thinking, well, there might be something different. But once again, we went from 13 to 25, which we had a change of 12 in the y value. Change in x, go from 6 to 12. Well, from 6 to 12, that's a jump of plus 6. So our change in x is 6. Once again, when we simplify that, 12 divided by 6, we get 2. So in either way, we're still going to find that our slope, or our end value, is 2. So now we know this much. Y equals 2x plus b. Still need to go find our y-intercepts. A couple of ways we can do this. We can solve for it, or we can even notice the pattern in the graph. And we notice that if we go back to, well, we're going to drop by 2 units, so we get to 0, which will give us our y-intercept. But if we drop by 2, we're going to have to take this guy back by 4. Once again, remember, we change by 4 every time we change by 2. So if we do that, we get 1. Because 5 minus 4 is 1. So that would be our y-intercept, 0, 1. And once again, that is like our b value. Or you can solve for it by plugging in one of the points. For example, any point will do. Let's do this guy. And I'll show you get the same result. So we're going to plug in that 9 in for that y. Plug them in right there. Take that 4, plug them into that x, and we'll solve for b. So 9 equals 2 times, once again replacing the x with 4, so 2 times 4 plus b. So then we get 9 equals, well, 2 times 4 is 8 plus b. Now to solve for b, we got to get it by itself, so we just need to move that 8 over. So to get rid of it on that side, we're going to subtract 8 out, because 8 minus 8 is 0, but what we do to one side, let's make sure we do to the other. So 9 minus 8 is 1. Of course, that becomes 0, so it kills each other, and we're left with the b. So b equals 1. Just take that, plug it back in right there for the b. So our equation would be y equals 2x plus 1. Looking below, we can see that c matches up with that. So c would be the correct answer choice here. Okay. Guys, there are so many different ways to solve problems. I'm just giving you different examples as we go along. You can choose whatever method you like, changing y. You can do y2 minus y1 over x2 minus x1. There's just so many different methods. At the end of the day, whatever you feel most comfortable with. Alright, so we can move along. Let's see. Okay, moving along. This time we are given a graph. Let's see if I can. Okay, it's giving me a hard time to squeeze it down, but let's look here. Let me try something here. No, not going to do much for me. That's fine. Okay, the graph models the value of a machine over a 10-year period. Okay, we see this graph here. Let's see what they're asking real quick. It says, what is the equation in slope-intercept form? Once again, slope-intercept form is that y equals mx plus b form. That represents a relationship between x, the age of the machine in years, and y, the value of the machine in dollars over this 10-year period. Okay, so we're looking for the slope-intercept form for this graph. Okay, so we can do a couple of things. We need to find our slope, our end value, and our y-intercept. Y-intercept is kind of easy to find, because we just need to find where our x is 0, right there, and then go up and find out what our y value is. So 0, 8 is one of our points. Now, make sure you pay attention though. Our value is in thousands of dollars. So that's actually going to be 8,000. So 0, 8,000. Very important point, because once again, that is our y-intercept, that guy right there. Okay, the only thing we need left to find is our slope. So we can find that by doing a rise over a run. And it's usually easier doing that graphically. So, once again, we find 2 good points. That was already a good point there. Once again, you want to find a point where your grid lines intersect with your graph. So this one looks pretty good to me right now. Okay, so going from here to that other point down there, it looks like we're going to go down 1,000, 2,000. So m equals rise over run. Okay, so we went down 1,000, 2,000. So indicating going down 2,000, we're going to put a negative to indicate the down. 2,000 over our run, which looks like we go, we'll make sure we got the right format. For every one, okay, for every one it's 1. We're going to go 1, 2, 3, 4. 4 years over. So our run is 4. Since we went right, it's positive 4, so 4. We'll simplify this down. We take negative 2,000 divided by 4, and we would get, I'll write it here, negative 500. Okay. Once again, we want in this form y equals mx plus b. Well, we found our m as negative 5,000. So y equals negative 5,000 x plus, or a y-intercept. But once again, like I said, I pointed at it. It's where your x value is 0 and what your y value is. So it's that 8,000 right there. So plus 8,000. So there's our equation. Let's see here. Let's see if there was answer choices here. Okay, no. Real quick, let me write it over here one more time. So we had y equals negative 500. Ooh, did I mess it up earlier? I said 5,000, didn't I? Yeah, it's not 5,000, it's 500. You see, we all make mistakes. All right, I'll just rewrite it down over here. So y equals a negative 500 x plus that 8,000 for our y-intercept. All right, so there's our equation in slope-intercept form. Okay, move on to the next problem. Okay, this time it says Jessica wants to go on a school trip next month. She already has $10 and plans to babysit for $5 an hour to earn the rest of the money. Write an equation that could be used to determine H, the number of hours Jessica babysat, and T, the total amount of money Jessica has earned. All right, well, we're going to let T equal our total amount that we're trying to save up. So let's go ahead and write T, kind of like saying Y. T equals, well, she already has $10. Let's go ahead and write that down. We're going to have $10 and plans to babysit for $5 an hour. So she's going to get $5 more an hour. So plus $5 an hour. So she gets $5 more every hour. So we're going to use multiplication. And we're going to use H as our variable. So 5H. Sorry. So there's our equation. I mean, you can rewrite it as T equals to make it more look more what you're used to, where you have that Y equals mx plus b format. And it really doesn't matter at the end of the day. So, but we could write it as 5H, 5 times the amount of hours that she works, plus the $10 she already has. Once again, this is a non-proportional relationship because this guy is not 0. It is actually some value other than 0. All right, pretty easy there. Move on to the next one. Let's see here. All right, so we're going to need to translate. It says, which table contains only V values and W values? So I'm guessing here our V values are independents, kind of like our X's. And our W values are like our Y's, our dependent values. Okay, so where the value of W is 5 less than the product of V and 0.5. All right, so we need to translate this real quick into a mathematical sense. So where the value of W is 5 less than the product of V and 0.5. So we're going to have, 1 second, make sure I write this correct. Now, so sometimes you want to read this over, and you might want to read it a couple of times yourself to make sure you get it right. But it's saying W is, or W equals, 5 less, so 5 less than the product of V and 0.5. So they're going to take, when they say product, they mean multiplication. So we're going to take 0.5 times V, and of course, taking that product and finding 5 less, so minus 5. So there's our equation. Now real quick, let's look at these tables. It looks like 6, 9 are V values, 6, 9 again, 6, 9, 12, 17 again, 6, 9, 12, 17, okay. And then it looks like we get different W values every time. So what we could do, this makes it pretty easy for us, is kind of make our own little table. Okay, so kind of putting inputs and outputs So I'm going to make a little table here. Sorry, my drawing skills aren't too great with this, but look, let's look here. V. Okay. Quick, I'm going to put a little equation here where W equals 0.5 V minus 5. When we input our V values, we'll get a W value. Okay. So real quick, we're going to do 6, 9, 12, and 17. Okay. So we have W equals 0.5 times 6. Okay, replacing that V with a 6 now. Minus 5. And we do the math there, 0.5 times 6, well that's 3, and 3 minus 5 is negative 2. So we should get a negative 2. So that should be one of our points. Okay, we get W equals 0.5. Put in one of my inputs is 9. Subtract 5. So 0.5 times 9 would be 4.5. And 4.5 minus 5 is negative 0.5 or negative 0.5. Once again, you don't have to do this mental math. If you have a calculator, go ahead and use one. All right. W equals 0.5 times 12 minus 5. All right, well, 0.5 times 12 is 6, and 6 minus 5 is 1. And lastly, W equals 0.5 times 17 minus 5. Well, 0.5 times 17 is, let me see, 8.5, and 8.5 minus 5 is 3.5. All right, so now we're looking to look for a table where we have 6, 9, 12, and 17, but 6 matches up with negative 2, 9 with negative 0.5, and etc. Well, clearly F doesn't do it, because when we plug in the value 6, we get 8, so that doesn't match up with what the table we created. Going down 6, and then it gets 3, so G doesn't work for us either. Okay, H shows 6 and negative 2. Okay, that does match up with what we had. 9 and negative 0.5. That does match up. 12 and 1. 12 and 1 matches up. And lastly, 17. 17 and 3.5. Well, matches up perfectly. So H is the correct answer choice. We look down 6 and 0.5. Once again, we know that's not correct. Okay. So that is one way to solve this. And they made it pretty easy for us because they gave us all the same V values. Sometimes they're going to make it a little more complicating. You have all these different V values, and then we're going to keep solving over and over again. But they made this one pretty simple for us. Okay. Moving on down. It's like the last one that we have here. Okay. Party Palace offers inflatable rentals for a non-refundable deposit of $100 plus a rental fee of $25 per hour. Which representation best shows the relationship between the total rental cost Y and the number of hours the inflatable is rented X? Okay, so real quick, let's change our sentence here to a mathematical sentence. So once again, our total cost Y is equal to, well, we have to pay $100 just to get started. So 100 plus a rental fee of $25 per hour. $25 every hour. We're letting hour being represented by X. So once again, it depends on how many hours we go, and we're going to pay $25 more. Or you can rewrite it, if you feel more comfortable, as 25X plus 100. Doesn't matter. Same equation at the end of the day. All right, so let's look through here real quick. Might be pretty easy. All right, so we do see that our y-intercept's 100. So when x is 0, we need to start at 100. So x is 0 here. Our y value is 100, so that checks out. All right, and then we're going to change by $25 every time. So for example, when x is equal to 1 or 1 hour, give myself a little room here. 25 times 1 hour plus 100. Well, we should get, 25 times 1 is 25 plus 100, we get 125. So at 1 hour, we should be at 125. It's going to do one more. Y equals, 2 hours. Take that 25 times 2 for 2 hours plus 100. And of course, 25 times 2 is 50, plus 100, we get 150. Alright, well, let's see if our graph matches up. So at 1, we should be at 125. So 1, 125. That does match up. And 2, we should be at 150. And that matches up. So it looks like answer choice A. Let's look at the other guys real quick and see why they might be wrong. Next, we got a table. It says at 2 hours, our total cost will be 225. Well, we just figured out it was 150. So, of course, that's not correct. Looking over here, it shows that 2 hours is $50. Well, we determined that wasn't correct either. And the last one, well, this one's pretty easy to eliminate because if you can see right here, it shows our y-intercept at $25. But we did determine that it had to be at $100 because that was the starting at 0 hours. We were going to pay $100 regardless. So that's why D is not a correct answer choice. Okay. Well, guys, that's the end of the lesson. I hope you learned something. Please check out any other resources if you need extra help or review over this video. I hope you have a nice day.